Aerospace and mechanical engineering are often a common toss-up for students because these majors are very similar, especially in the beginning of undergrad. The general difference is that aerospace engineering is more specialized, whereas mechanical engineering is more broad in terms of what you learn in school and the careers you can get into. So first, in terms of the curriculum, the first 2 years in both majors are nearly identical. You both take statics, which is the physics of systems that are not moving, so like analyzing a bridge and determining forces on various beams or cables, and basically everything in that class is broken down to the sum of all forces and torques is 0. Then they both take dynamics, which is the next class on systems that are moving. It's like the basic physics and mechanics you did in high school on projectile motion, energy, and momentum, just taken to a new level with more complicated systems, and calculus will be incorporated to find the force, torque, momentum, and more. And these two classes are the foundations for structures, which is why you can see mechanical and aerospace engineers designing the structure of an aircraft or spacecraft so that it can withstand all the various forces it's subject to. They go on to take different structures classes later, but the fundamentals are the same. And they also both use a lot of MATLAB. In fact, of all engineering majors, these two probably use it the most. For those who haven't seen what MATLAB is, it's a computer program that basically has built-in math tools to allow you to do a lot of things. As an aerospace engineer, you could plot the orbit of a satellite and have the program determine the equations of position and velocity over time. As a mechanical engineer, you could plot how heat moves through an object over time, given two different temperatures at each end of it. Now I want to get into fluid mechanics because both majors learn the basics of this, but I want to show how they diverge into separate topics. Fluid mechanics is about the physics of fluids, mostly air and water. Both majors start with the basics, but then you'll see how aerospace engineers go on to specialize in aerodynamics. So if you looked at an aerospace engineering test on aerodynamics, they might give you an airfoil and the speed at which it's flying at and ask you to solve for pressure over the wing. Or they might give you a missile-like figure, which will be simplified in terms of shape because you do calculations by hand, so we need simpler shapes to do that. They'd give you some angles and lengths that you need and say it's traveling at, let's say, Mach 2 or twice the speed of sound. Then they could ask you again to compute pressure at different points over the missile. Then they could also ask you to calculate lift and drag. These were actually a part A and B problem taken from an actual aerodynamics exam. So you see how this is fluid mechanics, but for a very specific purpose. And you're also doing things like supersonic and hypersonic aerodynamics, which mechanical engineers really don't go into. For the mechanical engineers, it's much more broad. They could give you some narrowing tube where the speed of the water is changing from the beginning to the end and ask you the acceleration at different points. They could give you a siphon problem and ask you to determine the flow rate based on various parameters. Then they could also give you an airfoil and ask you to determine lift and drag on it, even though you won't go into as much depth as an aerospace engineer. But then they could ask you the airspeed needed to move a golf ball off a tee based on radius and weight. So you see, you do learn similar topics and the foundations are all the same, but the aerospace engineers go on to learn more about aerodynamics, whereas the mechanical engineers learn a broader range of topics throughout their fluids classes. Now these examples that you see here are not exclusive to mechanical engineers. Some of these were very basic, and these were not to say that aerospace engineers won't learn these topics. Then the same thing goes for thermodynamics. Mechanical engineers learn a broad range of thermodynamics applications. For homework as a mechanical engineer, you may be given a heat pump that's supposed to maintain a house at, let's say, 75 degrees Fahrenheit, when from outside the temperature is maybe 40 degrees. Then they'll ask you to determine the minimum work input for 1 day of operation. Then later on you might look at gas turbines for aircraft propulsion, then you'd move on to modeling gas turbine power plants. Again, this is not to say aerospace engineers don't learn these because there is overlap. But you see how the applications are much more broad and you cover a lot of different things in your thermodynamics classes as a mechanical engineer. Aerospace engineers also learn the basics, but then those thermodynamics classes are actually a prereq for their propulsion classes. Mechanical engineers don't dive into propulsion in undergrad like aerospace engineers do. So for the aeronautical engineers, they dive into the turbojet and various other propulsion systems that are specific to aircrafts. You'll learn about all these various stages and do in-depth analysis on everything, like how pressure and temperature change throughout it. Then the astronautical engineers would learn about spacecraft propulsion systems. And you might be asked things like how much change in velocity can a certain propulsion method provide? And there are more differences between these two majors, like for astronautical students, they would take orbital mechanics and learn the physics of orbits. They could take spacecraft environments and learn about what we need to consider for things that go into space, like radiation as an example. Both disciplines will take different controls classes and so on. But now I'm going to move on to careers. For aerospace engineers, like I said, aerodynamics is more unique for them. This can apply to subsonic, supersonic, or hypersonic aircrafts. And aerodynamics can apply to cars, boats, missiles, and more. It's not impossible, but just less likely to see a mechanical engineer doing these kinds of jobs. Aerospace engineers can also work with the entire propulsion system, whether it be for an aircraft for the aeronautical engineers or a spacecraft for the astronautical engineers. You could do orbits as an astronautical engineer and plan the mission, as well as determine the orbits that are needed and how to get the spacecraft to the destination or into orbit properly. They can work on structures, which I said before is about designing the structure of the vehicle so that it can withstand various forces it's subject to. This could be for the landing gear, to the wings, to the passenger cabin, and also various parts of a spacecraft. They could work on controls, flight testing and performance, safety and reliability, and many more things that are specific and needed for an aircraft or spacecraft. But then mechanical engineers really can work in a huge variety of sectors. Mechanical engineers could work on the design of solar panels, wind turbines, a dam that provides hydroelectric power, or they could work in a nuclear power plant. They could do things from manufacturing these parts, making the blades of the wind turbine aerodynamic, and much more. They could work in the biomedical sector and make artificial limbs strong and durable, such that they can provide the right amount of force while not causing harm to the person. In terms of cars, they could work on the engines, the frame of the car to maximize its safety in the event of a crash, the suspension. If you go into mechatronics, you could work on the control system of self-driving cars, and more. They could work in petroleum engineering and help create machines to extract oil from the earth. They could work in HVAC and design the heating, ventilation, and air conditioning for a large building so that it provides proper air quality and temperature throughout it. They could work on roller coasters, submarines, and much more. Again, mechanical engineering is one of the most, if not the most broad engineering discipline. And when it comes to air or spacecrafts, mechanical engineers can also work on the structures, controls, I've heard of them working on the propulsion, and much more. There's honestly a lot of overlap with what these two majors can do. Aircrafts and spacecrafts need many types of engineers, so if you want to work in the aerospace sector, really just think about more specifically what about air or spacecrafts you have more interest in working on. And because of their similarities, not every university even offers a bachelor's in aerospace engineering. In general, remember, it's easier to get a job in aerospace as a mechanical engineer than it is to get a job outside of aerospace as an aerospace engineer. But it's definitely not impossible for aerospace engineers to branch out. There are aerospace engineers who work in the automotive industry, and even an aerospace graduate who's helped me with some videos works in the petroleum sector. And like I said before, especially with aerodynamics, aerospace engineers could work on boats, bullet trains, and so on. Remember, it's not so black and white as to which major can do what. Just know that you will see mechanical engineers in a wider range of sectors compared to aerospace engineers. Now, I've talked to various aerospace engineers and asked them what would you say to someone who cannot decide between aerospace and mechanical engineering, and they all said nearly the exact same thing. They said, if you know you want to work on aircrafts or spacecrafts and that's your passion, then go with aerospace. If you're not exactly sure, then choose mechanical. Because you can always switch majors, which is easier for these two disciplines because of the similarities. And then you can also always look for jobs in aerospace even as a mechanical engineer. And lastly, I've seen people ask which one is harder, and honestly, even if people tell you one is easier than the other, the margin is very small. You really need to consider what you have more interest in so that you can make a decision. If you guys like this video, don't forget to like and subscribe, and I'll see you all next time.